Okay, last section of chapter 10 is about what are called complex numbers. We already know that there's a problem when you try to take the square root of a negative number, like the square root of negative 9, or the square root of negative 15, or the square root of negative 1. That would mean the number that when you square it, when you multiply it by itself, you end up with that negative number. But a positive number times itself is always positive. And a negative number times itself is also always positive. So how can you start with a number, multiply it times itself, and end up with a negative number? Well, to be able to do that, we have to expand our number system to include the so-called imaginary numbers, and they're called that just because that's the name that got associated with them. It's not really that they don't exist, but sometimes we want to be able to work with numbers like that. So we introduce new numbers outside the set of positive and negative real numbers, and they're just called imaginary numbers. And those are the numbers that when you multiply them by themselves, you end up with a negative number. And that allows you to actually be able to work with the square root of negative 9 or negative 1 or whatever. So we don't have to keep writing things like the square root of negative 1. We use the letter I, a lowercase I, to stand for that so-called imaginary number that you get when you take the square root of negative 1. So it's not part of the real numbers. If you wanted to graph numbers on the number line, the positive numbers are on the right, the negative numbers are on the left, and then an imaginary number like the square root of negative 1 would be off the line entirely. It would be somewhere above it. So we use I to stand for the square root of negative 1, and that means that I squared would be the square root of negative 1 squared. Squaring undoes the square root and gets you back to negative 1. So it's important to keep in mind I itself is not just negative 1, it's the square root of negative 1. So that means that I squared is negative 1. So whenever you see I squared, you can just replace that with the good old number negative 1. So now we know what to do with the square root of negative 1. And then if we have the square root of negative 9 or the square root of negative 15 or the square root of some other negative number, what we do with that is we write it as the square root of positive whatever times I. So the rule is whenever you have the square root of negative something, write it as the square root of positive whatever times I. So for example, the square root of negative 9 would be the square root of positive 9 times I. And the square root of positive 9 is 3, so that would be 3I. The square root of negative 15 would be the square root of positive 15 times I. Or in this case, we might write the I in front so that it doesn't confuse anybody and make it look like the I is underneath the square root sign. The 15 is, but the I is not. So we can write it as I times the square root of 15. So with that in mind, let's look at some more examples. What is the square root of negative 64? Remember, what do you do whenever you see the square root of a negative number? You immediately write it as the square root of that positive number times I. So this would be the square root of 64 times I, and that would be 8I. What about the square root of negative 100? Well, that would be the square root of 100, which is 10 times I. The square root of positive 100 is 10, so the square root of negative 100 is 10I. And what if the negative sign was outside the radical sign? Negative square root of 100. Well, that would just be negative 10. The square root of 100 is 10, so a negative sign in front of that is negative 10. And what if we had negative square root of negative 100? Well, we've already said the square root of negative 100 is 10i. Now we've got a negative sign in front of that, so that's negative 10i. And what if we have 6 minus the square root of negative 100? We've already said that the square root of negative 100 is 10i, so 6 minus that would be 6 minus 10i. And what about the square root of negative 19? That would be the square root of 19 times I. Remember, the rule is whenever you see the square root of a negative number, that's equal to the square root of that positive number times I. And this is one of those cases where we might put the I in front to make it obvious that the I is not part of the radicand. The I is not under the square root sign. You have an I, and then you have the square root of negative 19. What happens if you have the square root of negative 4 times the square root of negative 25? Well, the square root of negative 4 would be the square root of 4, which is 2, times I. And the square root of negative 25 would be the square root of 25, which is 5, times I. So now we have a 2 times an I times a 5 times another I. The 2 times 5 would be 10. The I times I would be I squared. And do you remember what I said I squared was? Negative 1. So here we have 10 times negative 1, which is just negative 10. Okay, here's another one like that. The square root of negative 3 times the square root of negative 11. Again, whenever you see the square root of a negative number, you immediately turn it into the square root of a positive number times I. So we have the square root of 3 times I times the square root of 11 times I. And now we can put these together. The square root of 3 times the square root of 11 would be the square root of 33. And I times I would be I squared, which is really just negative 1. So now we have the square root of 33 times negative 1, or just negative, whoops, the square root sign doesn't go away, it's still there. So it's negative square root of 33. Now, remember when we started with 6 minus the square root of negative 100 and we wrote it as 6 minus 10i? Now, you can't simplify that any further because you cannot combine the 6 minus 10i. They're not like terms. The 6 doesn't have an I, but the 10 does. So that's as far as you can go with that. And something like that, that 6 minus 10i, is an example of what's called a complex number. And here complex means that it has more than one part. So whenever you have something plus or minus something else times I, that's a complex number. It's got two parts. The part without the I we call the real part. And then the part that is next to the I we call the imaginary part. So for 6 minus 10i, the real part is 6, and the minus 10 in front of the I is the imaginary part. So 6 minus 10i, or you can think of it as 6 plus negative 10i, is a complex number whose real part is 6 and whose imaginary part is negative 10. So complex numbers are numbers that can be written in the form a plus bi, where the a and the B stand for any real numbers, and the I stands for the square root of -1. So complex numbers, they are numbers, so you can do number types of things with them. You can add them together, subtract them, multiply them, divide them, and the result is always going to be another complex number. So let's see how that works. To add or subtract, you can pretty much use what you know about adding and subtracting algebraic expressions and combining like terms, and just think of the I as sort of like a variable, like X or Y. So for example, if we're adding 6 plus 3i plus 5 minus 2i, it's really just a matter of combining like terms. The 6 plus 5 combines to give you 11, and the plus 3i minus 2i combines to give you plus 1i, or just plus I. So the result is 11 plus I. How about subtraction? 8 minus I minus 3 minus 4i, this complex number minus this one. Again, it's just like combining like terms. We're taking the 8 minus the 3, and we're doing the negative I, or the minus I, minus the negative 4i. So the 8 minus 3 gives us 5, and the minus I minus the minus, and minus a negative is like plus a positive, the minus I plus 4i gives us a plus 3i. So the answer is 5 plus 3i. How about 6 minus 10 plus 7i? So the 6 minus 10 is -4, and then we have the minus 7i. There aren't any other I terms for it to combine with, so that's just minus 7i. So we end up with -4 minus 7i. Okay, I'm going to end this video here, and then I'm going to come back in part 2 and talk about multiplication and division with complex numbers. See you then.